Welcome back. This is going to be part 3 of 3 videos. This is 3 of 3 on round pump hacks, tips, and modifications. Part 3, back to the creek. Let me show you something interesting. All 3 of these things are swing type check valves. I've got a stainless steel, a brass, and another brass. They all look a little different. What they have in common is they are all 3/4 inch diameter. So what point I'm trying to make is that when you order your check valves, say for instance you've got a 3/4 inch round pump, not all check valves are built the same. Some are lighter than others, which means they're going to perform differently than others. This is something on Amazon. I'd call this the medium check valve. It's going to cost between 12 and 13 bucks on average for a brass check valve. And that's the one, if you purchase a round pump already put together, it'll probably come with something like that. If you go to a stainless steel check valve, it's so heavy, the flapping is so heavy, you're going to need a pretty good head to get that thing to function properly. On the other hand, if you have a very low head situation, low flow, you may want to get one of these check valves. It's 3/4 inch, but it's very lightweight. I don't have a model number, but when you go on Amazon, if you see this one for $12 or $13 and you see this one advertised, get 2 of them for the price of one, 2 for $12. That's your lightweight valve. And I'll go over here and show you the difference it makes. What you're looking at here is what I would call a standard size 3/4 inch check valve. It's pumping maybe once every second or so, which is okay. I'm going to replace it with this lightweight 3/4 inch check valve. Show you the difference. Look how much faster that thing's cycling. Now I won't say that's very effective right there going that fast, but if you check Land to House YouTube channel, you'll see some experiments he's done with putting 2 check valves on one round pump. And in his case, he had to put like 2 1/2 inch check valves on a 3/4 inch round pump system. Well, I tried that and it worked. But I also tried putting 2 of these lightweight 3/4 inch check valves on it, and that worked too. I got more water out of it using the 3/4 inch as I did. I got more water flowing through my pipe using 2 of the 3/4 inch lightweight check valves than I did with the dual 1/2 inch check valves on the same dry pipe. Don't be afraid to experiment with your round pump. Once you understand how they work, you can come up with all sorts of configuration. I'm going to change the configuration of this one today. Right now I've got a swing type valve going up to my pressure tank and a swing type valve used for my discharge or waste valve. Today I'm going to try moving this from the vertical position down to a horizontal position like you'd see in a linear round pump, and I'm going to move my check valve up to the front. So I just like playing around with stuff like that. You can too, it's a lot of fun. Now from my pump down this creek and up to my house is more than 750 feet. That's a long way. So when I do these experiments, I'll either take a pump up to my house and do it in my backyard, or I'll test it right down here. I've got a couple of short hoses, 50-foot hoses. I can make some adjustments to my round pump and check my water flow right here. That saves me a lot of steps. In a previous video, I talked about pressure gauges. I bought these from Amazon. They're called pool pump pressure gauges, and I love them because they only go up to 60 psi. That means the increments are so easy to read. If I, your typical gauge that you just screw into a garden hose fitting goes up to 200 psi, and if you're dealing with a system that normally operates between 5 and 10 psi, you need something that's going to be easier to read. When your ram pump is new, that's the best it's ever going to perform. I showed you some pipes up there when we began this video about all the crusty stuff that was on them. When these pipes are new, they're slick inside, but it doesn't take long for minerals to get deposited on it. And once the inner diameter of pipes, hoses, or whatever gets roughened up, it's going to greatly affect the efficiency of your ram pump. I'm going to go so far as to say you're going to lose between 5 and 10% efficiency for every 100 feet of, here I'm going to be talking about delivery pipe, but it also affects supply pipe too. I would say between 5 and 10% efficiency loss due to friction over time for every 100 feet. Right now, I'm going maybe 750 feet up to my house, and this system here, this delivery pipe, is only 2 years old, and I'm only getting 50% efficiency up there compared to the results I get here at the ram pump. Things other than friction that affect you would be sharp bends. Avoid 90-degree bends if you can. I've managed to stay ahead of the friction loss by using 2 pumps instead of 1. I have them connected with this harness here. This is for a washing machine. You can get this at any home improvement center. You don't have to do any plumbing with PVC pipe. This thing just screws right onto your discharge outlet on each of your ram pumps, and then you can attach it to your delivery hose. Just so happens I went ahead and put an on-off valve on my delivery hose, but it comes with a female, and a male connection there. Here's a modification I'm trying this morning. I haven't tried this one before, but I've moved my waste valve to the front, and here, instead of using a spring type check valve, I've just got a swing type check valve that's I'll have my pressure tank here, but this will be connected directly to my delivery line. And as I mentioned before, since I'm pumping downhill, I don't want to have to sit there and push that valve up and down 1,000 times to get water into my delivery line. Watch this. I believe when I turn on my supply, yes, water will just run right into my delivery line. And of course, when I've got my pressure tank and everything hooked up, that should get my check valve working. Yeah, we're going to try this out today. We talked about the differences in weight of the 3/4 inch check valves. Well, you can also make some replacements too on other parts. I've got 2 T's here and 4 nipples, close nipples. And you know how expensive brass is. Believe it or not, on Amazon, search for it. You can buy, sometimes you can buy stainless steel products just as cheap as the brass. And I don't know what I paid for these, but it wasn't that much. Probably less than $15 for 2 3/4 inch T's, and less than $15 for 4 stainless steel 3/4 inch nipples. obviously you cannot use a ram pump to pump downhill, because eventually it'll create a siphon which releases all the pressure on your pump and it'll just stop. But in a separate video I did last year, I proved that you can pump downhill provided you come back uphill. You understand what I'm saying? Water is going to seek its own level. In the experiment I did, I went downhill a couple of 100 feet into a ditch and then back up to my ram pump, and without the pump even running, the water came all the way back up to the level of my ram pump because it was seeking its own level. So yes, you can pump downhill as long as you end up going uphill higher than your ram pump. Of course, the big problem is how are you going to get water into that downhill hose to begin with? If you're using a spring type check valve at your ram pump entrance, it's not going to work. You can't just have water flow like I just showed you from gravity, because the pressure of the spring-loaded check valve is going to prevent your dry pipe water from going past that check valve. But I got an idea for you. Even though I'm using the swing type check valve on this system, once I get past all this, I could put a spring type check valve on there. This is a 5-pound crack spring-loaded check valve. In other words, it takes 5 pounds of pressure to open it. I could put it on there and it would pull my ram pump into thinking I already had 5 pounds worth of elevation, which would be about 10 to 12 foot of elevation. So I'm going to do an experiment here I haven't tried before. I already know I can get water through this new ram pump I'm designing here. I'm going to put this spring check valve at the end of this on the other side of my swing check valve, and we'll see if it will actually pump water downhill. All right, let me get this tightened up. Well, I think I'm going to have to put a pressure tank on here to get this thing to work. But as you can see, every time the waste valve cycles, water does shoot out through that thing. All right, let me get a pressure tank on here and we'll see how this goes. Okay, I got the pressure tank on there, and as you can see, there's quite a bit of water coming out. I'm going to try and measure how much water is coming out of that thing. You know, if you can get a 1/2 ounce per cycle, that adds up. If you're pumping every second, getting a 1/2 ounce every second, that means that you would have got pretty close to a quart in 1 minute, and that translates into almost 15 gallons per hour. I don't have enough room between my outlet and the creek to put my cup in there, so I'm going to try lifting this up. It may not even work if I raise it up too high. I'm going to try and get it up high enough to get the cup under it and let you know. I'm going to count the cycles and I'll let you know how much water I get in this 16 ounce cup. Okay, stand by. All right, I've just got a Y splitter on here. One side of the Y is completely closed, the other one is completely open. I'm just going to stick this cup in here and I'm going to try and count the cycles there. Well, I did something wrong. Shut off. Hold on. All right, let's try again. I think maybe I bumped it and it stood the check valve up to a position where it made it harder to cycle. We'll have to fine tune that in a minute. All right, here we go. Nope. Doing something. Let me turn this valve over just a little bit, a couple of degrees over, so it's not so sensitive. Well, I got it tilted just about 3 degrees. Try again. Go. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cycles, I got 16 ounces of water. Wow. I'm going to have to think about that for a minute. That's like amazing. That is amazing. All right, I don't have my clock with me. I'd really like to see how much water I'm getting out of here per minute. But anyhow, it proves the concept that by putting a check valve, not in the actual ram pump mechanism, but at the end of it, you can fake an elevation. I mean, if I didn't have that check valve right there, this pump would not be working. All the water would just come out of that pressure tank and it would stop working. I've got to think about this. This is a pretty good experiment. This is the sort of things you can do with your own ram pump. I'm tempted to walk up to the house and get my kitchen clock and my 32-ounce cup, hook a 50-foot hose up to that, and just see how amazing this is. Well, I've been standing here about 5 minutes and the pump is still working, and I've got it connected to my delivery line. So this is all I'm going to do right now. I'm going to leave that spring type pressure valve at the end of my system, and then maybe later today or tomorrow I'll come down here and actually remove that check valve and just connect directly to my delivery line from the pressure tank. Because I know that anything you put on a system that requires energy is taking away your efficiency. You know, any kind of restriction. I've got restrictions all the way down my delivery pipe because it's close to 400 feet from here down to where my delivery makes a 90-degree turn to go up to my reservoir. And I like it like that because I have 100-foot hoses. When it comes time for me to backwash or do, clean out something, I can just take the hoses loose at the junction. And actually I have Y splitters at each junction. And that way I can clean out one section at a time. Or if there's a problem, like a big tree falls on it and splits one of my hoses, I can just replace one section of it. Well, I'm back up here at my reservoir. Let me get over in the shade and we'll talk about what happened when I just tried that experiment by putting a spring type check valve on the delivery line. Okay, I'm not going to waste too much time in this video about what I'm doing down there. My point was to say, hey, it's worthwhile to do some experimenting with your ram pump, but I'll make a separate video regarding that. But just to satisfy your curiosity, when we were down there with no hose attached, we could fill up a 16-ounce cup in about 8 seconds. That means that if we had filled up 2 cups, it would have taken 16 seconds, which is just past the 15-second mark. In other words, I was getting very close to 60 gallons an hour out of that one ram pump, because there's 4 quarts to a gallon. If you can get a quart in 15 seconds, that's 4 quarts in a minute, that's 60 gallons per hour. The baffling part of this is that when I came all the way up here to my reservoir, it's taken about 35 seconds to fill up a 32-ounce cup. That means that somewhere between that ram pump and here, I'm losing more than 50% of my water, or my water pressure. Because if you get a quart in 30 seconds, that's 30 gallons per hour. If it takes you 35 seconds, then you're getting somewhere between 25 and 30 gallons per hour. That's a big difference between that and 60 gallons per hour. And this is going to happen to everybody. We were talking about friction loss. Through that hose, 350, 400 feet of hose, and then coming from that, I've got more than 300 feet of PVC pipe, maybe 400. So we're looking at 750 to 800 feet of delivery line here. And it's more than 2 years old. My PVC pipe I have is almost 5 years old. So I'm sure that they're pretty rough on the interior of that. And that's slowing down your delivery. To help explain that, let's say you attach your garden hose to a faucet on the outside of your house. And if you were to test the PSI, it might be a steady 40 pounds per square inch. That would be pretty normal for a lot of houses, 40 PSI at your spigot. Okay, then you hook up a garden hose to it and attach it to a sprinkler, and your sprinkler works fine. But then you move your sprinkler, it's not working good. Then you go check it, and there's a restriction in your garden hose somewhere, a kink or something like that. That doesn't change the PSI up there at your faucet. It's still producing the 40 PSI, but you've got a restriction in your delivery line that's not even giving you enough water to make your sprinkler spin around and around. I'm sure that's happened to you. Same principle could be happening to me. Half of my delivery line is running downhill, and then it turns and comes uphill on a gradual slope. So sand is a problem in my creek. If I was going to accumulate sand, it would probably be somewhere down around that area where my hose makes a bend. And if you have a situation like that, there's a couple of solutions. You can back flush, and I'll make a video about back flushing. But you can back flush from your reservoir all the way through that delivery pipe, all the way back up to the ram pump. Disconnect it from the ram pump. And if you use those Y splitters, then you can always keep water in your delivery line while you're doing these sorts of things. Something else I could do, and again, this is not going to be done in this video, is attach a pressure gauge to this outlet right here and see how it compares to the pressure down at my pump. I may be losing pressure somewhere. I'm using 400 feet of garden hose, plus a couple other things I have down there. I could be losing pressure at one of those connections. So it could be an obstruction, it could be a leak. What I'd probably do is back flush this thing, then check how many gallons per hour I'm getting out of my system. If it's still low, then I'd probably put pressure on this and close my valve up down on my delivery line at the ram pump and walk the whole delivery line looking for leaks. There could be a leak or something. But that's for another video. Again, the point was, don't be afraid to experiment with your ram pump. If you buy one, it might take you a season or two before you have enough gumption to do it. But if you've had one for a year or more, you finally understand what it's all about, and it wouldn't be any big deal to start taking that thing apart and rebuilding it. A little bit different design. Oh, what I failed to mention is critical was that I was so disappointed that I went from 60 gallons per minute down at the pump and only getting 30 gallons per hour. Wait a minute, let me say that again. 60 gallons per hour down at the pump and only 30 gallons an hour here. Hey, that's not unusual. That's what I've been getting for the past year, is I'm losing half of my potential somewhere between the pump and here, mostly due to friction loss in the pipe. But what made this so different was that, hey, I'm using 2 pumps. So it's like if I turn one pump off, I could probably still get this 30 gallons per hour. But I'm not getting the 2-pump reaction. So I've got a problem in my delivery line somewhere. I hope it didn't confuse you. I'm getting confused now. Let me move on from here. My goodness, I can't seem to get away from this friction loss idea. You know, if you got a dirty car like I do, you can put a beer can up on the hood and it's not going anywhere. Now, if I was to wash, wax, or ceramic coat this hood, I probably couldn't even put my towel up here. That thing would slide right off. So, you know, friction loss has a lot to do with the roughness of the inner diameter of your delivery line, but it also has other things that can attribute to it. Another reason could be a short turn. It takes more energy to make that 90-degree turn than it does to go straight. It could be the height. It could be an obstruction like sand in your pipe, or silt, or crawfish. That's my biggest problem is sand. But I also have problems with crawfish and tadpoles getting in my system. I don't know how in the world the crawfish get in there. Today I went down to the pump and a raccoon was using it like his own private bath. I don't know what he was doing. It looked like he was brushing his teeth down there at my waste valve. Washing his hands, brushing his teeth, shampooing. So a lot of things can affect the performance of your ram pump delivery. If you decide you want a ram pump, you can justify it very easily by saying, hey, it's a money-saving device. It's a green machine. It's good for nature. Almost all the water you take out of it is going right back into the creek. More than 90% of the water that goes through that dry pipe is being put right back where it came from. 10% being put on the ground. It's good for nature both ways. But if you want to know the truth, there's more to it than just being a device. A ceiling fan is a device. A toaster oven is a device. There's something about a ram pump that it can turn into a hobby, like hunting, fishing, golfing, boating. Nobody who gets addicted to fishing has just one fishing pole. God knows what my fishing shed looks like. It's amazing. And same thing with a ram pump. After a year or two, you're going to end up with a treasure chest full of spare parts, which will allow you to build more ram pumps and do more testing. Ram pumps are healthy. I mean, you can get on that treadmill for 15, 20 minutes in the morning, listen to all the sad news on network TV, or you can put your rubber boots on, walk through the woods down to the creek, just to take a look around, make sure everything's okay, and come on back home. It's not only been good physically, but being in that environment heals the soul. You'll be able to go to that crummy job, shuffling papers, counting beans, or whatever you do, and you'll have a better attitude if you spend a little time in the woods each morning. I think it's healthier than being on that treadmill. Well, that's just my opinion. That pretty much wraps up this series of ram pump hacks, tips, and modifications. If you stuck through all three parts, I want to thank you for your patience. And I also want to make some apologies. I've done this many times before. I'm not monetized in any way. I don't try to be monetized. That way I'm not going to be one of these guys begging for you to subscribe or click the notification bell. I'm just not going to do that. That irritates the heck out of me when I'm on YouTube checking other things. But I haven't, I hate to say this, but I don't read my comments. 90% of them are just so supportive and pleasant, but there's another 10%, I don't know why, there's a certain group of people out there who just want to be negative. And it doesn't matter what you're talking about, somebody's going to find something wrong with it or find some way to offend you. And I just don't need that in my life. I have a very serene life here, and I don't need trolls stepping on it. I haven't blocked my comments because I want you guys to have access to the platform. If there's something you have to say, go ahead and put it in the comments. I may not read it, but your neighbor might. You know, somebody might get something helpful from what you have to say. I might be wrong about something. You're more than welcome to tell me if I'm wrong. That will help anybody else reading those comments. And anyhow, I hope you understand what I'm saying about that. I also want to apologize about being so illiterate when it comes to computers and stuff. I'm in my mid-70s. It took me a year to figure out how to post a picture to Facebook, a still picture to Facebook. I live by myself here. I don't have anybody young to show me how to do these things, so I don't know how to make a playlist. But you know how to spell my name. And if you're looking for something, you just go on YouTube and search it. I don't have all those algorithms to where it just pops up automatically. It's kind of hard to find my stuff sometimes. But in some way, I do pray that at least something I've said could be helpful to you. I have one last apology to make. Well, it's not an apology. It's about how I sound. I was raised in the South, and I'm proud of my heritage, so I can't apologize for that. I'm very proud of it. But I understand it's hard for you to understand me sometimes. I'm also recovering from throat cancer. So if you have a hard time understanding me, after my videos have been up for a few days or a week or two, it seems like YouTube will go ahead and install closed captions on there. So if it sounds like I'm speaking a foreign language, go ahead and click that CC button and maybe bring up some closed captions, and that will help you understand some of the things I've said. Thanks again. Good luck to you with your ramp up.